On Friday, August the 27th of 2021, the saltwater intrusion team conducted a program in person at the Pasquotank Extension Center to share what was currently known as a result of their investigation of saltwater intrusion in Northeast North Carolina. The following presentation, along with others, were later recorded by the presenters to share their information. This presentation will provide a timeline as well as the details for the Pasquotank and Camden County Agland saltwater intrusion problem. To ensure that everyone is aware of the topic, saltwater intrusion is when saltwater combines with freshwater in surface waters and groundwater, or when saltwater moves across land surfaces and negatively impacts the soil and groundwater. My name is Al Wood, Extension Agent for the Pasquotank County Center of the North Carolina Cooperative Extension Service. In 2014, fields were identified that were affected by saltwater intrusion. Since then, additional fields have been identified in Camden and Pasquotank counties. Growers and landowners that are impacted by the problem are asking their extension agents a wide array of questions on this topic, including, is this something that can be corrected? With the assistance of Dr. Crozier, now retired extension soil specialist of NC State University, it was determined from soil samples and observation from soybean fields that there were elevated levels of salts in the soil that could not be explained by the normal production of crops. The next several slides are of soil samples for some of those fields. Soil samples submitted to the North Carolina Department of Agriculture and Consumer Services Soil Lab can be either predictive or diagnostic. Predictive samples determine the fertility status of soil for crops to be planted and provides recommendations, whereas diagnostic samples are taken from problem areas to determine if adequate fertility or other soil chemistry factors are contributing to the problem. These are diagnostic samples as noted in the red box in the top left corner of the report seen here. With diagnostic soil samples, two parameters related to salts are provided: exchangeable sodium percentage, ESP, and soluble salt index, SSI, as seen in the red boxes in this report on the right. Soil samples for predictive purposes only provide ESP. Without getting into the details for exchangeable sodium percentage and soluble salt index, since Dr. Gattoboni will be covering them in more detail in a presentation later on in the program, just remember that when we get values for ESP of at least 10 and soluble salt index values of at least 50, then salts start impacting the soil, the plant growth. Diagnostic soil samples were taken in two spots in the field: a good area, samples G1 and G2, and bad area, B1 and B2. At each spot in the field, samples were also taken at two depths, with B1 and G1 at a shallow depth, and with B2 and G2 being deep samples. As seen here from the bad area, B2 and B1, the ESP and SSI values were much higher than the good area and indicates the presence of salts. With the B2 sample, notice that the ESP and SSI values are in a range where the salts can adversely affect plant growth. These are samples from the same field, but from a good area, G1 and G2. The values for this spot in the field where the soybeans looked less affected by salts had values for ESP and SSI that were much lower than the samples that were taken in the bad area. Here is a diagnostic soil test report from another field that was suspected with being affected by salts. The samples B1 and BE were taken from bad spots in the field, and again you see that the ESP and SSI are higher than they should be under normal conditions, although the BE sample has higher values than the B1, which indicates that the salt content of the soil varied from one spot in the field to another. Again, the BE values for ESP and SSI are within the range that can be detrimental to plant growth. This is another sample from the same field, but from a good area. The ESP and SSI are much slower than the bad areas. This is the third field with a sample from a bad area, B1, with ESP and SSI values several times higher than the values from the good area of the field as seen with sample G1. The ESP and SSI values for B1 are slightly less than what would cause salt issues with plant growth. This is a field that a grower in Pasquotank County said that he was having problems with salts. Notice the area where there are no soybean plants. The salt levels were so high that it actually killed the plants. With a closer look at the soil, as seen here inside the red circles, the white patches are salts that have accumulated on the soil surface. Here's an image of a soybean field in Camden with barren spots where the plants have died, as well as other plants that are succumbing to the salt. Here's a more panoramic view of the same Camden field with large areas where there are no soybeans. In 2018, Austin Brown and I created this map to locate all the fields that were known at that time to be affected by saltwater intrusion. Notice that in both counties, it is in the lower end of the counties where the fields are at lower elevations in relation to sea level. In 2018, Dr. Diana Rasage was contacted and agreed to lead the investigation of saltwater intrusion problem in Northeast North Carolina. She, along with the extension agents, brought together a collaborative team. This team consisted of farmers and landowners, extension agents for Pasquotank, Camden, and High County centers, as well as extension specialists from NC State University, researchers from the Geology Department of East Carolina University, as well as representative of the Albemarle Soil and Water Conservation District. Monitoring wells were installed in the fall of 2018. Geophysic measurements, including electrical conductivity and electrical receptivity, were completed in the spring of 2021, along with deep soil cores taken with a geoprobe. In the summer of 2021, an elevation analysis of the sites was completed. Following a meeting of the team to get an idea of the problem in Camden and Pasquotank, a visit of sites in these counties were conducted in the spring of 2018. In the center is Dr. Carl Crozier with the bucket auger. To the left is Austin Brown, Extension Director and Agent for Camden County, and on the right is Brian Lannon with the Albemarle Camden Soil and Water Conservation District. This is Dr. Diana Rasage in the spring of 2018. A hole was bored into the ground with the bucket auger, and the groundwater was allowed to fill the hole so that Dr. Rasage could take measurements of salts in the groundwater. This image was taken in October of 2018 when wells were installed to monitor salinity and groundwater levels. In the top right corner with the red ball cap is Dr. Alex Manda of the Geology Department of East Carolina University, along with assistants. At the Pasquotank County site, 3 spots were selected with 2 wells each, 1 shallow and 1 deeper. Depending on the study site, the number of wells varied. 2 sensors were placed in each of the wells, 1 for water level and 1 for salinity. This is the image of one of those sensors. This image was taken at the Pasquotank site at one of the 3 spots with wells. Not only were wells installed, but also several sensors to measure the soil moisture content at different depths in the ground. The box on the post between the 2 wells has equipment for recording the soil moisture data. A weather station was also installed to collect data such as wind speed and direction, as well as rainfall. Any data that might help determine what factors could play a part in saltwater intrusion was collected. Dr. Stephen Moisey, also of the Geology Department of East Carolina University, collected data for electrical conductivity and electrical receptivity, as seen here. This equipment is for electrical receptivity. The saltwater intrusion team, upon looking at the initial information from the sites in Camden and Pasquotank County, asked the question, where do we go from here? The team decided what needed to be monitored as well as put together the resources to accomplish it. The other presentations of this August the 27th program will address other aspects of this investigation. Hopefully, this program today will help those people that have questions regarding saltwater intrusion to be more informed of the topic.